Okay, so quick recap, and then chapter 6.6, arithmetic series, and then geometric series. I do want to talk about what series means, just so that you know the difference and know how to, I guess, react or respond to a question when you see it. But the two written questions that I have here are from the previous chapters. The first one is an arithmetic sequence. So take a look at some of the keywords. At the end of the second week, I need to make this bigger. At the end of the second week from the grand opening, so week 2, a new fitness club has 870 members. At the end of the 7th week, there are 1,110. If the increase, so that should give you a hint that it is not a multiplication, okay, is arithmetic. How many members were there in the first week? So let's break this down. First week being term number 1. It's another way of saying, what is the A value? In the second week, I know this to be 870. And by the 7th week, so the 7th set of, I guess, members, 7th time we count how many members we have, there's that. If the increase is arithmetic, then we know that it is this. Looks oddly familiar to one of the elimination and substitution questions we've had. Okay. Give it a shot. I'd like to give you just a minute. And if you think this is easy enough, I'd like you to try the second. Give an honest chance at doing the second question. That is a geometric sequence. Okay. Assuming if you are joining through video, I'm hoping you had a chance to pause the video. I'm going to do both questions right off the bat. The first one is very similar to the elimination question that we've done. We know that, I guess we could use the logic way. I'm just going to go ahead and just do the elimination way because it shows some structure without explaining. T2, which is 870, is also equal to A plus 2 minus 1 times D. I don't know what D is. So it's basically A plus D. Oops. There. Next, T7, 1110, is A plus 7 minus 1 D. So 6D. If I were to subtract the first equation with the second equation, I would get myself 0, 4, 2. Correct me if I'm wrong. A minus A, thank you, is nothing. And D minus 6 is negative 5D, which makes my D value 48. Great. I can plug this into any of these equations I want, but I think it's easy to do the first one because that's T2. T2 being 870 is equal to A plus a 48. That means the starting value when we first opened up this club was 822 members. Done. Okay. The next one's going to be interesting. This is a Sierpinski carpet. There's a lot of different patterns that I think borrow this name, but this is the major one. Correct me if I'm wrong. Don't quote me there. The Sierpinski carpet, basically, we are looking at the gray area. So right now, this is 100%. We can say that this area is 1. It really doesn't matter. We can say that this area is 10. We can say it's 1,000,000. You can say it's 999. It really doesn't matter. Whatever number we start with, take a look at the next one. How many pieces did I divide this carpet into? 9. How many of those pieces are shaded? 8. So in terms of the entire area, 8/9 of this entire carpet of an area of 1 is shaded, right? So if you think about it mathematically, so stage 1, so T1 is just the entire thing is shaded, but T2 8/9 of it is shaded, right? Because this square was cut into 9 pieces and one of them was left out. Now, removing ourselves from the white square, we look at all the new gray squares that we created. Every square, so each gray square, is cut into 9 smaller squares, leaving the middle one white. So this square, 1/9 of it, is cut into 9 pieces, and 8/9 of it is shaded. 8/9 of this is shaded. 8/9 of this is shaded. 8/9 of this is shaded, so on and so forth. So you can try to count all the different small squares, which is going to be annoying. How many white? So 9 squares, 9 squares, 9 squares. This would have been 9 squares, 9 squares, 9 squares. You have 81 small squares. And out of those 81 small squares, 1, 2, 3, 4, 5, 6, 7, 8. And this would count as 9 squares, right? 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8 times 8 plus 9, so 17. Is no, the other way around. Sorry. So if I have 17 that are white, then 81 minus 17, that gives you 64. Yeah, 64 of these are still gray, right? And so it would be really annoying to actually count how many gray squares are available. But you might recognize a pattern with the numbers 8 and 9. So mathematically speaking, you can instead say, okay, T2 is, come on, T2 is 8 out of 9. But out of the 8 of 9 squares, 8/9 of the 8/9 of the squares is gray. I'm sort of butchering the words here, but I think you get the point, right? Out of this, the previous 8 gray squares, 8/9 of it will still remain gray. And then T4, out of the original gray squares, another 8/9 of it is going to be gray. So you're going to start seeing a pattern where we continue to multiply 8 over 9. 1 times 8 over 9 times 8 over 9. And so I think you can establish that just from this, the area, also the ratio is going to be 8 over 9, and my starting value is going to be a 1. Write a formula to determine the shaded area. Shaded area is 1 times 8 over 9 to the power of n minus 1. Determine the shaded area at stage 20 to 20, and that is 8 over 9 to the power of 19, which I'll leave that to you to figure out. But it's as simple as that once you see it. But at the beginning, it might be a little complex. Take your time with puzzles like these. If I ever give you something like this on a puzzle in a problem set or whatnot, there's always some method of identifying the ratio. Yes. Oh, it's a 1d minus 6. So it's negative 5. Does that make sense? Or am I missing something? So 870 minus 1110 gives me negative 240. A minus A is nothing, and 1d minus 60. Negative 5d. Okay, and that's it. So I guess a final taste of arithmetic and geometric sequence before we move on. Any questions? No? Okay. Then let me, before I get flagged, quickly do attendance while you take a break. Will, Claire, Josh, Anna, Josh, Sid, Talia, Jose, Daniel, Monica, Abby, and Lynn. Excellent. Yeah. All right, let's get to this. I'm going to go straight ahead and take a look at our handout 6.6. I'm going to demonstrate what a series is based on just a silly example that I've made. And then we'll look at what the formula is. We'll talk about where the formula came from, and then we'll start using it in funky creative ways. And we'll try different types of questions that try to twist the words on you so that you don't, fall through the cracks. And then we'll take a break. Okay? Again, today we'll have a lot of time on our hands. So when I do give you a break and I give you like 30 minutes, don't just walk around with it. Try to do some of the textbook questions. It'll really be helpful in preparing for something like a problem set. Okay, so let us start with arithmetic series. Here it is. Okay, so again, please recall, as I say, anything arithmetic is going to involve a difference, not a ratio. Okay, so here's a scenario. I'm going to draw some pictures. Hopefully you're able to visualize it. And from there, it'll make the equation that much easier. Mr. Kim is hosting a super fun imaginary party. 20 super fun math teachers are invited and arrive. Spelling error. Wow, I need to change that. One at a time. When each guest enters, they high five with Mr. Kim and anyone else who is already there. How many high fives occurred in total? See if you can catch how this is different than an arithmetic sequence. Okay. How many high fives occurred in total? So I'm going to use a thinner pen. So let's pretend this is me. I'm happy. Okay, that's Mr. Kim. And then the first guest arrives and they're like, yo, high five. With me so far? That's one high five. The second person arrives, term 2. Second person arrives and they're like, yo, what's up? High five? High five. How many high fives? In total, right? 2 high fives. There was 1 in the past, so in total there's now 3. Next person's like, yo, what's up? Okay. And then high five, high five, high five. So 3 for that stage, which means a total of 6. And then this person's sad because there's so many high fives to do. 1, 2, 3, and 4. Okay. So if you think about it, the guest number is also equal to the number of new high fives, right? Or number of additional high fives. So if we were talking about the total, it's not 1 and then 2 high fives and then 3 and then high fives and then 4 high fives. As Josh was saying, I'm not counting just the high fives. I'm actually counting the total. So first one is a 1, right? If there's 2 people, then I have to add a 2. If there's 3 people, it's 1 plus 2, and then I add the third one because there's 3 more high fives. And this is 4 high fives. So it's not this. This would be a sequence. What is a series? A series is when we are interested in calculating the sum of the sequence. Right here. The arithmetic series is the sum of the terms in an arithmetic sequence. So before we use the formula, A plus n minus 1d to figure out what the number was. Now, after we find all the numbers, we have to add them. How are you going to do that? Well, you're stuck. We might be able to think about a creative way. Okay. I like to compare my students and see how you do versus Gauss. If you know Carl Gauss is a pretty famous mathematician, pure mathematical theorist, and there are what is it? There are um, math contests named after him. If I asked you to follow this and I said 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, all the way to 20, without actually adding it, without doing the grunt work, could you figure out, can you tell me what the total might be? Do you see a pattern? And I'll tell you this, the answer is there are 210 high fives in total. Yep. Yeah, you know this? Where did you hear this? Oh, did you? Amazing, amazing. So we got one person. Can you think about a pattern? It's a trick. It's not even a pattern. You have to use a trick to identify or to calculate what the total is. And using that trick, we find the formula. Like literally the formula is using the trick in a short way. So think about it. Yes, it is. Exactly. Yeah, we're cutting in half. Exactly. Okay. Anyone else? No, you're clearly getting some hints, but when if you sort of listen to what Monica and Jose was saying, clearly you're not just adding. It's a weird trick that you're using. Think about it. How would you add the first 20 numbers without doing the work? It's really not easy if you don't see it. But that's the brilliance of Gauss, right? Like he was in middle school. He was in middle school and he was bored. And the teacher, and I guess he was annoying because the teacher was like, "Here, let me keep you busy. Go over there into the corner and add the numbers 1 to 100." Right? And if you think about it, most kids would be like 1 plus 2 plus 3. Like even if you use a calculator, it takes a minute. It takes a minute, right? Oh, there, yeah, it is. Exclamation is actually multiplication, so it's even more complex, right? But this is what Gauss did. I'm going to clear this. Let me show you his both his brilliance, but more just creativity, the power of strategy. Let me write this out. If you have the sheet on the sheet, if you want to follow along, um, just write 1 plus 2 plus 3 plus 4, dot, dot, dot. And then we'll jump to 98, 99, and 100. That's our goal. There are 100 terms, and I need to add all of them. What Gauss did wasn't add 100, but what he noticed was if you take a look at the first number and the last number, it's the same sum as if I were to increase by 1 and decrease by 1. What is 2 plus 99? 101. If I increase by 2, I decrease by 2. Does that change the sum? No. So what he did was essentially, I'm going to take a Kyla, exactly. He took the first half and cut it in half. He took I need a color that shows up. He took the second half and he cut it in half. He essentially took it, he folded it. He folded it so that 1 is paired with the 100, 2 is paired with the 99, 3 is paired with the 98. And we get ourselves 1 plus 2 plus 3 all the way to 50. And then I fold it. So we have 51, 52, all the way to 98, 99, and 100. If I add them together, which is what I'm trying to do here, the sum, I get 101 every single time. How many times am I doing this? 1 to 50, half of the numbers we're adding. We are adding So the sum of 1 to 100 is actually 101 50 times. It's 5050. It's brilliant. I wouldn't be able to do that when I was in middle school. Okay? I was interested in Pogs and my Sega Genesis and Transformers when I was in middle school, right? That was my childhood. And so this is where we get our formula. Let me try to write this out just to tell you where this comes from. Do you notice how I am adding essentially the first term and the last term, right? It's equivalent to the first term and the last term. So this is T1 plus Tn. And then I am multiplying by a 50, which happens to be half of n, half of 100. So you take T1 plus Tn. I wrote T2 for some reason. T1 plus Tn multiplied by the total number of terms divided by 2. That's all it is. It's brilliant. But the applications of this is immense. And let's hash it out. If you remember, what is the definition? What is the formula for T1 in terms of A and D? Because this is arithmetic sequence, or arithmetic rather, you can write T1 as A, right? Because the first number is A. And what was our definition for Tn? If you look above, Tn is equal to A plus n minus 1d. So if you simplify that, I have this formula right here, n over 2 times 2 times A plus n minus 1d. Or if the arithmetic series gives you the first and last term, you can use this instead. You will get the same answer either way. Quick disclaimer, I'm not going to ask you to memorize this formula. You will always have it with you, whether it's in the formula sheet or just available in your notes. So you don't have to worry about memorizing, but you do have to work on reading a question and recognizing what type of question is it. Is it a sequence? Is it a geometric sequence? Is it an arithmetic series? Read the question and identify that first, and you will be going in the right track. Okay, that's the worst thing. You're trying a question. Another hint to know that it's a series is you don't see that word, the letter Tn is not there. You see that there is Sn, which stands for sum, right? If the question asks for Sn, they're asking for the sum of a certain number of terms. To finish my explanation, I'm going to do one example, and I'll stop to see if there's anyone who has questions, and then we'll try some of the other questions on the back. All right? So bear with me. I'm going to do one more explanation by doing a question together. Determine S20, in other words, the sum of the first, I'll write it here, sum of the first 20 terms. That's what this means. Okay. Determine the sum of the first 20 terms of the arithmetic series. So they tell you, which means this would be my A value, and I could figure out what the D is just from 2 terms. So again, the word reveals so much. My A value is 3. My D value is 5 minus 3, because that would be, remember, that's still term 1, and this is still term 2. But instead of a comma, I'm simply adding them all, that's all. So term 2 minus term 1, my difference is a 2. And this would be term 20. So we could do it a couple of ways. I'm going to show you how you can use both formulas. But there are some questions where you can't use both formulas because it's too hard to use one versus the other. It's a lot easier to use the other. So let's do this. For the first one, S20 is, remember, n over 2, T1 plus T20. I could do that. Right, and T20 would be what? 2 times n, that's 40, 41. It would be 41. So you would get, I don't have space, 20 over 2. The first term is 3, and the last term is 41. That would be a 10 multiplied by 44. My final answer is 440. Let's do it the other way. S20 is n over 2, 2a plus n minus 1d, right? If you remember, this is the first term plus the last term. So that is equal to 20 over 2. My a value is 3, and my d value is 2. So 2 times 3 plus 19 times 2, which gives me 10 times 6 plus 38, which is 10 times 44, 440. Either way is okay. Okay, quick pause. Any questions? Yep. Oh, it's this. So yeah. So the question was, can you explain this portion of the formula again? Absolutely. If you remember, the formula said n over 2 T1 plus T20, right? But in fact, T20, I put T20 there because that's the last term we care about. That could just be Tn. Whatever the last term is, I'm adding that last term. Just like in my example, it was 1 plus 100. I'm just looking for the last term. But also remember, from my arithmetic sequence question, the general term for Tn is a plus n minus 1d. Remember from 6.4? That was the equation for a sequence. So if you don't know what the number is, it's okay. I can figure it out. T1 is the first term. It's always 1. And Tn is a plus n minus 1d. I'm adding the 2. So my bracket is actually just this. So there's the first term, and that's the last term. Yeah. No, it would specify. We're just assuming that that's going to be the last term. So if n happened to be a 20, that would be 19. That would be 2a plus 19d. Whatever the last one we care about. Yeah. Right. So I'm using n because I don't know what that number is. But if we did, you just plug in the n there, it becomes something d. Yeah. Okay. Good. Any other questions? Okay. I told you, we have a lot of time. That's 6.6. It's just a matter of you practicing. I'd like you to try what looks fun. We could try number 2 and maybe try number 5. Number 2 and number 5, I'd like you to do it right now before we go for a break. But Before you get started on it, I just want to do a quick plug just to show you, do you see how this can apply to money again? Just like 6.4 and 6.5. I'm looking at how much it is. I'm adding another value to it in the future. It may or may not make sense, but this is going to have a direct application to savings. Like for example, just a silly example, right? Let's say when you're a kid, you're saving like a dollar a month, right? And then you realize you can save more, so it becomes $2 a month. And then the next year you're starting to work at, you have a paper route when you're like 12 years old, so you save $3 a month. So the amount that you're saving increases. How do you account for that? If you use an arithmetic sequence, you can. It's hard. If you want to see the total amount of something and that number is constantly increasing, right? It's like $1, then $2, then $3, then $4. How much do you have after that, right? It's all trying to relate to money in a sense when we get to the financial. I hope I can continue to keep your interest. Please try numbers 2 and 5 right now. We'll take it up together at maybe in about 10 minutes, and then we'll go for a break. We'll try number 2 together first, just to make sure everyone is on the right track. Again, if you're joining through video, you should pause the video and try it. Okay, determine the sum of the sequence. I know it says sequence, but the keyword there, it already tells you it's a sum. So I want the sum of some number of terms. The reason I'm leaving it as an n, because I don't know what that term number is. There's a bunch of ways we can go about it, but if you remember the equation, yeah, I do need to know what the n value is, right? Either formula, whatever formula you use, I still need to find it. If I don't have n, we're screwed, right? So there's a hidden way of saying, go find n first, and then we'll deal with the sum after. Let's do this. Knowing that this is, well, it's a sequence. Let's pretend we didn't know if it was arithmetic or geometric, okay? So you would try it. Is it a difference? Well, negative 35 minus a negative 31, negative 35 plus 31, the difference is negative 4. Is it consistent? Difference, if I choose negative 39, I would subtract it with a negative 35, which gives me negative 39 plus 35. Yeah, it's consistent. So I know that this is arithmetic. Okay. It would be terrible if you thought it was something else, or if you thought it was arithmetic and it happened to be geometric, right? So right now, I know we didn't have to do it because we didn't learn geometric yet, but it's a good thing to practice, okay? So I know it's arithmetic, and I've identified D. Identifying D, the question also gives me the value of A. So I have two very valuable pieces of information, which I am going to use to finally figure out the n. Because again, if you don't have n, you're sort of screwed. Tn is equal to, well, negative 403. But that happens to equal to a plus n minus 1 d. Negative 403 is equal to negative 31 plus n minus 1 times negative 4. So I'm going to do some algebra. Plus 31 plus 31. This becomes negative 372 equals n minus 1 times negative 4. Divide both sides by negative 4. 93. That means n is going to be 94. Sort of a backdoor way of doing it. So now that we have D, we have A, and we have n equals 94, we know that this entire sequence has 94 terms. So the question is actually asking, what is the sum of the first 94 terms? Whew. can see the questions are getting a little bit more elaborate. So sum of 94 using the formula, 94 is going to be cut in half and flipped on, squeezed on top of each other. And what is it that we're multiplying? We are multiplying, or sorry, what is it that we're adding together? The first term is added with the last term, and that's going to be multiplied by the number of terms divided by 2. So we're doing the same trick that Gauss was doing. We have 47 multiplied by negative 434, which I cannot do in my head. I wish I could. That would make me feel pretty nice about myself. 494 times 47. 434 times 47. Negative 20,398. There it is. So as a quick recap, for a question like that, 1 second, we had to identify it, right? Sum means we're using the series formula. Number 2, we checked if it was arithmetic or geometric or not. Like, is it a difference or is it a ratio? Oops. A or D. Oh, sorry. D or R. And then for this one, we needed to okay, we need either the first term and the last term, or we need A, D with the N. But either way, we needed the N. But if you have that, you're just plugging into the formula and away you go. Okay? Hope that sort of makes sense. Please try the last question. It's still 10 minutes till 10. So try the last question and then check your answers with me on the board. And then at 10 o'clock, I will stop all of you and force you to take a break. Okay, so push on until 10 o'clock. Okay, just a quick teleport. Let's see. Let me do the answers secretly so we can see that there's Sarshi. Nitro has 3 more seats, 14, and then 14. Seats. That's basically what it's saying. 14, 14, and 4. Plus 14 times 2 plus 13 times 3. 14. So the answer is 469 seats. See if you can do that. Okay. How do you feel about that amount of time was given? It's a little short. I like to work through it to show you how, quickly and methodically you can pull out the important numbers, and then most of the time can be spent actually doing the calculation. Consider this. In the theater, there are 14 seats in row 1. Automatically, that should ring a bell saying the first number is 14. Each row has 3 more seats than the row before it. So it's going to be 17, 20, 23, so on and so forth. And I do this for 14 rows of seats. In other words, the N value is 14. How many seats are there in the theater? By that, they're asking for the sum, right? They're asking for the sum of the 14 rows. So just, again, looking at the wording, pulling out what they actually want you to do. And from there, let's start figuring out the pieces so we could put it together in a formula. That's essentially the goal of all of these pattern questions. The N value being 14 rows, there's going to be 14 different numbers that we're adding. The first number also is a 14. And in this sequence, it says 3 more seats. So we know that the difference is going to be 3. And lo and behold, we have N, A, and D. We already have the combination that we can just plug that into the formula. Sum of 14 is going to be N divided by 2 multiplied by 2 times A plus N minus 1 times D. Done. That's 7 multiplied by 28 plus 13 times 3. That's 39 plus 28. 39, 28, 57. 57 times 7. 67, sorry. 67 times 7 should be 469 seats. Okay. A lot of these patterns is just patterns. Your goal, for at least for arithmetic series, you're just going to need a combination of certain numbers and just plug into the formula. I think the hardest part is reading a question and knowing that it's arithmetic or geometric. So keep an eye out for that once we get to chapter 6.7. Yes. Yes, that's essentially what you're doing. This part right here is the last number, right? That's 14 plus 13 times 3 is the last number. And then you added one more 14. That's the first number. It's exact same thing. Exact same thing. Okay. Yeah. I'm gonna stop the video here and we can take our break. I don't even know how much I want to give you because you don't have too much left.